A pH meter is an electronic device used for measuring the pH, which is acidity or alkalinity of a liquid, through special probes. Those special probes are sometimes used to measure the pH of semi-solid substances. So it's basically for liquids, but if we use special probes, we can actually look at the pH level of semi-solid substances. A typical pH meter consists of special measuring probe, we'll talk about the probe in a minute, which is basically a glass electrode. It is connected to an electronic meter that measures and it displays the pH reading. Now the probe itself, let's look at the picture. We actually immerse the probe into the liquid. The probe is a key part of the pH meter. It is a rod-like structure, usually made up of glass. At the bottom of the probe, there is a bulb. Now, the bulb is a sensitive part of the probe that contains the actual sensor. Never touch the bulb by hand, and clean it with the help of an absorbent tissue paper with very soft hands. We don't want to scratch it. We don't want to physically actually damage it. That's the sensor itself. Being careful not to rub the tissue against the glass bulb in order to avoid creating static electricity. To measure the pH of a solution, the probe is dipped into the solution, as we can see actually in the picture. The probe is fitted in an arm known as the probe arm. This is actually what this particular person is holding while dipping the probe into the solution. And as a general actually information, we're actually looking at the pH scale. Now, pH scale is very, very interesting one, where number 7, which is the central point in this scale, is a neutral type of value, neutral value. From 0 to 7, we're talking about acids. From 7 to 14, we're talking about alkalines. 0 to 7, 7 is natural, 7 to 14, alkalines. And if we're really looking at the bottom part of the picture, we can actually look at a little bit more details of what happens in this scale. So when we're actually talking about very much acidic materials, as an example, stomach acids. And then we have the neutral, which is water. And then in the alkaline, in the green side, okay, we have the baking soda, which is very, very high pH level. And if I'll go a little bit more in depth to different type of materials and applications, we actually can see that the battery acid has a very, very low level of pH, same as lemon juice, same as vinegar. And in terms of the other side, the alkaline, we have the milk, we have the ammonia, and we have the Li as we go actually toward number 14, which is the end of the scale. Now, how does a pH meter work? A pH meter measures the concentration of the hydrogen ions in the solution. An acidic solution has far more positively charged hydrogen ions in it than an alkaline solution when we compare. So it has greater potential to produce an electric current under certain conditions. That's acidic. It is like a battery that can produce a greater voltage. Let's look at the picture. In this glass that we can see, glass tube, we have a reference solution. That reference solution is, there is an electrode, which is a reference electrode dipped into the reference solution, and it's the reference level, a known reference level. It goes to a meter. The other side of the meter, the second lead of that material meter, goes into this test solution that we want to measure. And it has its own blue electrode on the right-hand side. And the difference between the two is basically being displayed. So we have a known reference level of pH being compared against an actual one, and we measure the difference. Now, it takes advantage of these and works like a typical voltmeter. Known on one side, actual in the other side, the difference between the two in terms of volts. It consists of pair of electrodes, we saw it, same picture here. They are connected to a meter capable of measuring very, very small, low level of voltages in the order of millivolts. That's how sensitive the system is. It measures the voltage produced by the solution. The voltage is basically the electrical potential. And it compares it with the voltage of the known standard solution. Uses the difference in the voltage, which is basically associated with the difference in pH. And if we look a little bit more in depth into what actually consists of glass electrode pH meter, we can see the glass part on the left part, which we actually have the reference. And in this particular case, we have a KCl in 7.0 pH, normal, a KCA solution. It's a reference solution. Goes to one side of the voltmeter through a coaxial cable. Very important. And the reason we want a coaxial cable is because it is very low level of voltage, millivolts. So the reason we're using coaxial cable is to isolate the wire, the conductor, from the surrounding, not to have any kind of electromagnetic noise and any fields coming and affect these millivolts of readings. Because we are talking about the reference. Same thing on the other side. The tested probe is on the right hand side, and it's dipped into the solution. And the voltmeter, so-called voltmeter, compares the two readings. The standard one from the left and the actual one on the right. But in order to make sure that we actually reading the proper pH meter, pH levels, we need to calibrate the pH meter. It's a very, very important procedure. Critical to understand and appreciate and conclude from the reading. So when we do read 7.9 in this pH meter, we need to make sure that when we read the 7.9, it's actually 7.9. For this, we need to calibrate the device. And this is for very precise work. The pH meter should be calibrated before each measurement. So sensitive it is. And calibration should be performed with at least 2 standard buffer solutions. The previous picture showed the procedure, the parts and how it consists of. Now we should actually use 2 reference solutions that span the range of pH values to be measured. We want these standard solutions, not actually to have one of them on 7.0 as a reference, but we want in different levels of standards. So we make sure that we cover the entire scale. That's a proper calibration. Now for more precise measurements, a 3 buffer solution calibration is preferred. So we make sure that actually we cover the entire span of the scale. And the calibration process correlates the voltage produced by the probe, which is approximately 60 millivolts per pH unit.